Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is lesson 1.2, increasing and decreasing functions. Let's get right to it. Today we're going to determine the intervals for which a function is increasing or decreasing. We're going to use the terminology to find a maximum or a minimum of a function. We're going to discuss some symmetry of a function, and then we're going to determine if a function is even or odd. So let's have some definitions of what that is. A function f is increasing on an open interval from a to b if for any x1 and x2 on that function or that interval a to b, x1 is less than x2 implies that f of x1 is less than f of x2. Now that's a lot of words, and I get it. And it doesn't necessarily make a whole lot of sense unless you draw a corresponding picture. So let's take a look at this thing right here, and let's turn off these numbers because we really don't care about them a whole lot. And let's kind of break down what it says here. A function f is increasing on an open interval from a to b. All right, so the first thing we need is some open interval a to b. All right, so let's draw in an interval. So I pick my pen tool, I go like this, I'm going to call this a, and I'm going to call this b, and we need a function that's increasing. So I'm going to draw in a function that does this. That works good for me. All right, so let's go back to the definition. Here is my function. That looks like it's increasing. And so if I pick any two values, x1 and x2, such that, oops, I went too far ahead, x1 and x2, if I pick that such that x1 is less than x2, so let's pick two and label them properly. So I'm going to pick this point right here. I'm going to call it x1. I'm going to pick this point right here. I'm going to call it x2. And clearly, x1 is less than x2. And so if x1 is less than x2, that's going to imply that f of x1 is less than f of x2. All right. And so if I follow this up right here, and I follow it over, this point right here is f of x1. And if I follow this up to here, and I follow it over, and I go f of x2, and clearly f of x1 is less than f of x2. And so what it says is that if you have some interval that you're calling it to be the function to be increasing over. If you pick any two x1, any x1 and x2, such that x1 is less than x2, then if you follow them up to the function values, the f of x1 will also be less than f of x2. And clearly, if I pull this up, if I picked any two x1 or x2, and the x1 is less than x2, then the f of x1 will be less than f of x2. For a decreasing function, you get something similar to that. So let's say I call this a, and I call this b, and I again pick an x1 and an x2 so that x1 is less than x2. And so I have that. That's going to imply that f of x1 is greater than f of x2. Okay, well that makes sense too, because if I follow this point up to here, and then I follow that over, this point right there is f of x1. And then if I follow this up to here, and then I follow this point over, that's f of x2. And so if I were to pick an x1 and x2 such that x1 is smaller than x2, then clearly f of x1 is going to be greater than f of x2. And that's what you have when you have a decreasing function. So relative minimum is a similar expression. If I'm going to call f of c a relative maximum, if there exists some interval between x1 and x2 so that any x that you would pick between these 2 points, that f of c will be bigger than f of x. And then if you do it for f of x, or c will be smaller than f of x for a minimum. And then for a maximum, that f of x or f of c will be greater than the f of x. Now, again, we get something that's not real easy to understand in the words, But when we draw a picture of it, if we're trying to do, and we'll follow the minimum like we have in the notes here. So I'm going to draw a relative minimum, and I'm going to say that this point right here is my relative minimum. So again, I'm going to turn off the numbers because they don't really make a whole lot of sense in this particular instance. And I'm just going to call that this point right here is my C, and this is my F of C when I follow that point over there. If I have an open interval x1 to x2, and I don't know why they didn't use a and b like they did in the first one. If I were to pick any point x in here, so I'm just going to randomly pick this point here and call it x, and I follow that up, and then I follow that point over there, I get f of x right here. And so for C to be a relative minimum, over this interval here from x1 to x2, any point that you pick x, the function value of that x has to be bigger than the function value of whatever that C is, and this is my relative minimum. Now we can do the same thing for maximum. If I call this point right here my maximum, here is my C, here is my F of C, and if I talk about an open interval from x1 to x2 and relative to the general values around there, any value x that you were to be picked, if I follow that point up and then I follow it over, this point right here will be f of x. And for it to be, or f of c to be the relative maximum, then the f of x has to be smaller than the f of c. And clearly we see that to be true. Increasing, decreasing, maximum, minimum using the graphing calculator. To find a relative maximum or minimum, use the calculate menu. We're going to move our spider guy a small amount to the left of what the supposed maximum or minimum is, and we're going to press enter. Then we're going to move the spider a small amount to the right of the maximum minimum and hit enter. And then we want to move the spider guy close to whatever the maximum minimum is and press enter. And what you'll see is they're finding the intervals for where to check for the maximum or minimum. And then the intervals for increasing or decreasing are open intervals because they do not include the maximums or minimums. All right, and I'll show you an example of that here shortly. Test for symmetry. A graph is symmetric with respect to the x-axis if for every point x, y on the graph, there's also the point x negative y also on the graph. And a graph is symmetric with respect to the y-axis if for every point on xy on the graph, negative xy is also on the graph. And a graph is symmetric with the origin if for every point xy on the graph, negative x, negative y is also on the graph. Now, these are important because if you have symmetric to the y-axis, it is another term for an even function. And if you have origin symmetry or symmetry with respect to the origin, it is an odd function. Symmetric with respect to the x-axis will not be a function, so they don't talk about that in general. So examples of functions with symmetry, with the exception of this one. This is not a function, so I should note that. And so if we were to solve this for x, the graph of this thing would look like this. If I go -5, it would open like this. And clearly it's symmetric. If I were to fold along the x-axis, it would fold, but it would line up on either side. But this is clearly not a function because it doesn't pass the vertical line test. Symmetry in the y-axis. This one's very easy to graph. If I go -4, it is a parabola that opens up on the x and the y. And if I were to fold along the y-axis, it would match up. And then symmetry in the origin, this would look like that. And 1, 1 also has a corresponding point, -1, -1. So any point that has an xy value also has to have the same negative x, negative y value. Testing for symmetry. If you want to test y-axis symmetry, substitute both x and negative x into the function. If the resulting y is the same as the original function, then it has y-axis symmetry. Substitute both y and negative y into the function. If the resulting x is the same, then the function has x-axis symmetry. And origin symmetry, substitute both x and negative x as well as y and negative y, and that all yields equivalent equations, and you'll have those symmetries. Functions that are even or odd. A function is even if for each x in the domain of x, negative x yields the original f of x, and a function is odd when for each x in the domain of f, negative x yields negative f of x. So conclusion, a even function is symmetric about the y-axis and an odd function is symmetric about the origin. And we'll talk about the examples here very quickly. So let's do an easy one. Let's bring this all together. We're going to determine the intervals on which a function is increasing or decreasing, and then we're going to determine any relative extrema, and then we're going to say whether the function is even, odd, or neither. All right, so we're going to use technology to do this. So I'm going to bring this up, and we did stat plots later. We haven't, or in the last chapter, and we haven't done anything with our calculator, graphic calculator since, or at least I haven't. And so just as a reminder, if you look here and you get an error, notice I have this plot right here that is highlighted and these two are not. This stat plot might give me some problems. So the easy way to turn it off is just to go up and hit enter. That'll turn it off for us. We'll clear out that stuff, and then the equation that they gave us was x squared plus x. And we're going to hit graph to that function, and let's go back and zoom back to a standard window. So zoom 6, and so we want to figure out where this function is increasing and or decreasing. All right, so it looks like it's decreasing to about there, and then it starts increasing from that point on. So the first thing we want to do is we want to find this relative minimum. So we're going to hit second, then hit the trace button. We've already done value, we've already done 0. Now we're going to do a minimum. So I'm going to hit 3. And we want to go a little bit to the left of where we think that minimum is. And so I'm going to hit enter. And then we're going to go a little bit to the right of where we think that minimum is. And we're going to hit enter. And so what we've done here is we've set up an arbitrary interval in which the graphic calculator is going to look for the relative minimum between these 2 points. So I want to put my spider guy right close to where I think it is. I'm going to hit enter, and here we have a little bit of an issue. If you get 0.5 with 1, 2, 3, 4, 5, 0, just 4 zeros, and then a 1, I can pretty much guarantee that that's a rounding error by the calculator, and it's negative 0.5. And then the y was negative 0.25. And so we're actually going to answer the part B question first. So A, we haven't done. B, we're going to say there is a relative minimum at negative 0.5, comma, negative 0.25. And if you wanted to use fractions, if you wanted to say it was negative 1/2, I can't use a bracket there, negative 1/2, comma, negative 1/4, that would also be acceptable. There is no relative maximum. And in this case, this is actually also an absolute minimum because there is no value that's lower. Now, what finding the maximum and minimums do is it finds the points where it changes from increasing to decreasing, or in this case, decreasing to increasing. So from negative infinity up until this point right here, that function is increasing or decreasing. And then from that point on, the function is increasing. So we can say that this function is increasing on the open interval from negative infinity to negative 1/2, 0.5. And then it is, oops, I screwed that up. I apologize. I'm sure that you guys Saw my mistake right away. Decreasing from that interval, and then it is increasing from -1/2 to positive infinity. Now, is this function even, odd, or neither? All right, so here's what we're going to do. We are going to compare f of x, which was x squared plus x, to f of negative x. All right, so I'm going to plug in negative x. So negative x quantity squared plus negative x. Well, negative x times negative x is just x squared, and then plus negative x is like minus x. And so we ask ourselves, is f of x equal to negative x, or f of negative x? That answer is no. These two things are not the same. All right, so we can conclude f is not even. All right, oops, there's too many expansions. And then I'm going to compare this function to negative f of x. Negative f of x means that I multiply the entire function by negative x. All right, so if I multiply f of x times -1, I'm going to get, and I made a mistake there, negative f of x. To get negative f of x, we're going to multiply by -1. So I'm going to write that. To get negative f of x, multiply f of x by -1, just so that I get that clearly across to you. And so when I multiply this expression by -1, f of x becomes negative f of x squared becomes negative x squared, and then x becomes negative x. And so if negative f of x is not equal, or is equal to f of negative x, since that is also a no, we can conclude that f is not odd. So f is a neither function. All right, let's try that one more time. One more example with a similar function. And so I'm going to go to my graphic calculator. I'm going to go to my y equals. I'm going to clear this out. I'm going to go x raised to the 4th. Oops, I don't want that. I'm going to clear. Let's make this a 4 plus x squared. I'm going to hit graph, and I get this function right here. And so again, it looks like I have just a single relative minimum. And so I'm going to hit second. I'm going to hit my calculate. I'm going to do a minimum here. Go to the left, hit enter, go a little bit to the right, hit enter, go to where I think that minimum is. That's pretty close. And you'll notice we get this little symbol here and this little symbol there. This is scientific notation. This says 1.46 times 10 to the -6th power. So I've got a decimal point. I've got 5 zeros and then I've got a 1. Here for this one, I've got a decimal point. I've got 11 zeros and then a 2. So both of these we're going to consider to be 0. So in this case, C, we have, or for B, we have a relative minimum at 0, 0. And for A, it is decreasing on -infinity to 0, and then it is increasing from 0 to positive infinity. And now we want to determine if it's even, odd, or neither. All right, so we take our f of x, and we say f of x is equal to x to the 4th plus x squared. And then I plug in f of negative x. All right, and so negative x gets raised to the 4th, and negative x gets squared. Now when I multiply a negative by itself 4 times, because it's an negative times a negative is positive, times a negative is a negative, times a negative is positive, this thing becomes x to the 4th. And then when we square a negative, it's also a positive. Now, I'll notice that f of x is equal to f of negative x. And that's a good thing right there. That tells us that this function is even. Now, since it is even, it can't be odd and it can't be neither. That means we are finished with this particular function. And clearly, if I look at this function, it is symmetric to the y-axis. And that gives us an even better, or makes us feel even more confident with our conclusion that this function is even. That's all I got for today, folks. So today's Marvel fun fact of the day, Gal Gadot, who eventually went on to become Wonder Woman, was in the running for the role of Nebula for Guardians of the Galaxy. That role eventually went to Karen Gillan, who gained fame. That should not F-A-I-M, that should be F-A-M-E. Come on there, McCully. From her role in Doctor Who. She was Amy Pond, if you're a fan of that. Well, that's all I got for today, folks. Have a good day. Goodbye.